Hi everyone, welcome on this new episode on the Module17 Revision 1 rework. So, on today's I forgot to. Okay. So on today's episode, we are gonna try to draw the new schematic for the audio output filter, and then we will try to start reworking the board for its new shape according to what we need for the enclosure that we plan on using. So on the audio, we have basically this, which is this is the power amplifier, which will provide the oomph, the power for the speaker, because the speaker is low impedance input, well, let's say. So the audio comes from here, which I think comes directly from the microcontroller. So we can check, I guess here, no, sorry, other sheet. Okay, so this is analog output from the microcontroller, which comes here, is first filtered, and then we have this, which is basically variable gain for the power amplifier, so that we can choose the gain. This is gonna change a bit. We are also gonna change the low pass filter because we want another architecture, let's say. This is passive filter based on resistor and capacitor. The problem with that is that the impedance of the filter is not constant across the spectrum range, and also it's at least 22 kilo ohms, which is a lot. Then we have this, which is used to set the gain of the amplifier, so basically the output volume. And so this we are gonna replace with what is called a Sallen-Key filter. Basically have an amplifier inside the filter, and so you have a much lower output impedance filter, and also the curvature, the baud plot, so the frequency response of the filter is much better, much flatter across the whole frequency range. Then we are gonna have either this one or another one, which I'm not sure yet which one we are gonna use. Maybe we will switch to a filter an amplifier which can provide 3 watts, because we might need a bit more output power. And then we are gonna go to the speaker. So yeah, this is what we need to do first. So we will. Hi Hervé, how are you doing? Nice to see you here on time today. So okay, we will go first and design the Sallen-Key filter, which we will not do like by hand. So Sallen-Key filter design tool, I think this one is gonna be good enough. So this is a unity gain, so it doesn't amplify the signal. If you do amplify the signal, it's gonna change the frequency response. And given that we want a gain which we can modify to have like a full range audio output from 0 to 5 volts, so the full power, we'll need at some point to have an amplification, because the output here is at most 3.3 volts, and then because of the way codec 2 is encoded, I've been told that we must consider that this is about 2 volts output. So we'll have to amplify it 2.5 times, which I think we are gonna do that in the power amplifier, which is also gonna have a variable gain. So this is gonna be a good start, I think. We want a damping factor of 1. So basically it means that there is no resonance in the filter, and the gain is at most 1. We want a cutoff frequency of 4000 Hz, 4 kHz. This is the sampling frequency of the output. And it gives us, wait, I had another kind of answer a few days ago. What happened? Let me check. Yeah, I had this one. So this is, for example, a silent key filter. If you run the simulation, yeah, this is what I was talking about, because this has a gain, which is set by the divider here, and because of this, the frequency response increases near the cutoff frequency, which is bad, basically. It's going to distort the spectrum. So if you remove the amplification and have a gain of 1 at most, and rerun it, then you see that it's flat from 0 to basically the cutoff frequency, then it starts lowering, of course. So if you have a look here, at about 3 kHz, it's at 4 kHz, sorry, it's about -3 dB, which is what we computed. So, okay, I don't know what's going on with this one. Why is it not the... Oh yeah, okay. Wait. Okay, I was sure that it was displaying like other values, but whatever. Is it like because of this? Huh. Okay, whatever. Anyway, quality factor is of the filter doesn't mean that the filter is gonna be bad. It's just gonna mean that there is not gonna be a spike at the end of the filter, which is what we want. So those are the values that we are gonna use. We also need an amplifier, and for that, for now, I think we might use an MCP6002, just because we already have them on the board, so that we don't add a new part to this. So I guess this is the one I need to use. Let me just check quickly. What is this one? Oh yeah, okay, MCP, okay. Amplifier operational, MCP602. Oh, okay. Well, I'm gonna reduce the same part as they did, but as Matthias did, sorry, but maybe we are gonna change that later on. So we have 3 parts because it's a dual amplifier in the same package, and then we have this, which is the voltages. Okay. So basically, this is getting a bit crowded here. Maybe we should add a new page. How do I do that? I forgot how I have to add a new page. Connectors, and sheet is gonna be connectors.kicad.sch. Well, okay, that's done. So then I'm gonna be able to move this from here to here, those one, and this one too. Here, do we have any connectors here? Yes, USB-C. Goes from here to here. And we have any additional one? Those are not really connectors. And yeah, maybe this one, so that all the connectors are on the same sheet. And here, oh yeah, we have those that we will move to. And yeah, this one, which I'm gonna move to. So this is supposed to be connected to V in. So I'm gonna do this and put this here. So this is connected together, but the connector is on the same as another. Sorry, the connector is on another page. So all of them are grouped on this page. Nice. Leaves more room on the other sheets. Oh, and this one has to go right here. Great. So now we have a bit more space and we can reorganize a bit. This, oh, can I maybe... Squeezing it a bit so that you have enough room for everything. Okay, perfect. This, oh yeah, this is the V for the voltages for the analog amplifiers. And maybe I can move this down here. This is audio, or maybe, let me think. So we need to make more space on the schematic because we won't be able to draw everything, and I think it's even more logical if we add yet another sheet, one for the baseband filters and one for the audio filters. So let me go here, connectors, I want that on the last as the last sheet. And then we can create the baseband schematic. Oh, yeah, crap. We'll take care of aligning everything later on. Anyway, we have... Oh, this sheet is not named correctly. Can I go and... We need a capital C. Yeah, great. So here we can now move this to this page. And I think, yeah, this one needs also to move. Here, and I think I do also need to, so U501 and U502, oh yeah, but okay, those have been renamed. It's gonna be annoying, but it's not a problem. So I think this one, and this one, they need to go, no, on the baseband page here. Yeah, U501, U502, great. So U502 is here, U501 is here, and I will lay that out cleanly later on. Okay. So now we have like plenty of space. We also have this, which, yeah, maybe it's not the best page to put that on. Don't know. Not a big deal, we will take care of that later on. Most important is we have plenty of space, and we can now place the filters that we will design. Put this here, this in the corner, and this is gonna be modified, so let's put it in the middle of the page while we work on it. So basically, audio speaker is gonna come here. Output is gonna go so this label is gonna be connected to the input of the silent key filter, which is gonna have an amplification of 1. So this one, I don't think we are gonna use it. I'm not sure though. For now, I'm gonna put X's if I can, to say that it's, oh, no, misclicked, to say that it's not connected. Like this. This one is gonna be the one doing the work. If we have a look back at this, we can see how we are supposed to draw it. So let's just place the components we need, which are resistors, and it's the small one, R small. We need 1, 2, and we need 2 capacitors. Like this. Let's lay them out the same way they are laid out on the web page. Don't overcomplicate it. So the output goes to this cap, and this cap goes right in the middle of those 2 resistors, and we need more space here to add capacitor, like this. This capacitor goes to ground. You can just copy a ground symbol like this, and this one goes to the outputs because it's unity gain, so there is no voltage division in between the feedback and the output of the amplifier. This is the output. So this is, so from here through this we arrive here. So this we can get rid of it. Except that we also need to set the voltage, the values of the resistor, which is 7.5K for this one and 4.7K for this one. C1 is gonna be 10 nanofarad, and this one is gonna be 4.7 nanofarad. Great, 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 great. Okay, perfect. Voltage rails. Let's just check how they did it, how Mattis did it. Yeah, here, I guess. So we'll just basically do the same as here. So we go to audio and filter, paste this, except that we don't need. Okay, wait, how can I? Okay, yeah, like this. Good. Okay. And VAA, so it's basically VAA is a filtered 5 volts, okay. Okay, yeah, I would have used a 3 volts, maybe. How is the 3 volts generated? It's an LNA, sorry, not an LNA, an LDO from the 5 volts. So this most probably has less noise. Let's just check quickly. So this, and also we need to see how this one works. I want to see the hashing frequency. Do they state that somewhere? Interesting. They don't. Or maybe they do. What's the time base on this? I can't really read that. Oh, 2 microseconds maybe? So it would be 1.5 cycle per 2 microseconds. Just a quick computation. $750 kilohertz. That seems a lot. Oh yeah, okay, I can't do any search on this. Maybe it's given somewhere for confirmation. Not a lot of information on this component, looks like. Anyway, I don't really like powering such an amp directly from a DC-DC converted supply. So I would prefer to use the 3-volt supply, which is VDD. So basically, I think I'm gonna, oh, this is, okay, I'm not gonna do that. I'm just gonna wait for the module 17s I have, which should be on their way, and when they will be here, I will do a few measurements to see the noise on each bus and which is the best one to use. Given that there is already this possibility, I'm gonna use it. Okay. Next up is amplification, power amplification. So from here, we will have to go to here somehow. For that, I'm gonna rely on the datasheet of this one. Oh. So basically, and we are in this configuration because we have a single-ended output for the speaker. So of course it's gonna be less than 1.5 watts because of the single-ended supply output. If it was being true differential output like this, then we would have twice the voltage across the speaker, which would bring 4 times the power. So I think that if we have a look here, we already have the positive input is connected to the bypass and to this 100 nanofarad cap. The negative input is connected to this, which I'm not really sure what this is supposed to be. We have this resistor in the feedback, which is okay, in parallel with 15 picofarad. Okay, I think it might have been for the gain, maybe. Okay, do we really need to modify this? I'm not sure, actually. This test point I'm gonna move. So this was working previously. So basically the only thing we need to do is add this filter. This is gonna be, have a much lower output impedance, which makes it so that the voltages that arrive on the input of the power amplifier are gonna be from 0 to maximum 3.3, and that's less than that because of the impedance of the filtering. So this should sort things out already. So we can do this, remove this wire and join those two. So this is gonna be our new audio output, I think. So I'm just not sure why this resistor is here. I don't tend to do a lot of power amplifier design, so I'm not really sure what this is for. Worst case is we can try to see what it does in LT-Spice. Maybe I'm gonna keep that for later on. Let's try to keep moving here. Okay. So audio output from the microcontroller, filtering, amplification, speaker. Great. This is the power supply for this filter, and this amplifier is not used yet. Maybe it's gonna be used later on, I don't know. Okay. Let's go on the Taiga project to see if that's everything we had to do. Oh no, we also already sorry. Forgot that we also had to do the potentiometer things. Okay, this yeah, I'm gonna take care of cleaning up things later on. Okay, so find a new audio amplifier. I think in the end we decided on going for MCP. No, sorry, LM4991. I think it's a drop-in replacement anyway, so except if we go for the 3-watt one, but we are never gonna have 3-watt output power. Yeah, okay, we are gonna do a modification. And so this one is gonna become LM4991. Is it somewhere in the... No, it's not. Maybe we can go in the library editor. Oh, I think it's better if I do like a new symbol derived from this one. And let's check if the pinouts are the same. Shutdown, shutdown, bypass, bypass, plus, minus. Yes, the pinouts are the same. So basically LM4991XX, I think, because there is the 4991 and 4991LD for the WSUN package, which supports a higher output power because it's able to dissipate more heat because of the heat, the external pad, which can drain the thermal power. Let me just check quickly to verify that it is indeed correct. Yeah, 4991 LD that has been properly mounted to a circuit board will deliver 3 watts into 3 ohms. Okay, so 4991XX. So we can't modify the graphics because it's based on that one, so this is correct. But we can, however, modify this. the data sheet, we can copy paste this, and then we are good to go. So basically now I can place the LM4991. Yep, misclicked. Interesting. Wait, did I forget to save something? Because it's not the correct name. Oh yeah. Value LM4991XX. Okay. Mouse part number. This is not good. Mouser, we don't want this. Height, we don't really care. This field and this field either. We'll have to add one field later on, and the description hasn't been modified. Oh, that's very strange. Anyway, LM4991XX. Okay, this. And boom, we changed the power amplifier. Well, let's check that the pinouts are the same between the two, because I think I checked previously, but I'm not sure now. Shutdown is 1, bypass is 2, input positive is 3, input negative is 4, output 2 is 8, ground is 7, 6 is VDD, and 5 is VO1. Okay. So, just like this, we have more output power. What do you know? Okay, now to the potentiometers that we have to take care of, which I think it's this and this. Is it? Yeah, I think it is. Okay, I'm not gonna try to understand everything that has been done in the past. It's not my job. I'm confident that they did a good job because it's already working somewhere in the world, so we don't need to take care of this too much. Anyway, so okay, what I want to do now is first go on git kraken and commit the fact that I added the filter. Hi Foche, nice to see you. I just added the, I don't know if you've seen, I just added the silent key filter and decided to remove to update the amplifier to pick the higher power one. So this is what it looks like now, with the silent key filter right here and the amplifier, which basically I touched nothing from here to there. Let's commit this. For the rest, this has nothing to do with what we did. Okay, so I'm gonna close this, and I want to go back to this commit. And now open projects and this one. And I want to see how it was done in here. Okay. I'm gonna open this as a picture, screenshots, and so this one and this one. Wait. That's weird. Okay, let's go back to check out this commit. Oh. Okay. Okay, so how was it done? Okay, so this one is here. So basically this has been replaced with this, simply. And if we go have a look at this, no, wait. Hey, I opened two pictures. Where is the second one? Or can, oh, we can only open one at a time. Too bad. Let's go back. Open project 0.1D. Let's just take a picture of it all, like this. Oh, no music, you're right. What did I use as music? I think it was royalty free. What kind of music? Yeah, this is gonna be less boring with music. Okay. Okay, so I have a picture of this to compare the new schematic with. Close this. get rid of these file changes, check out the last one, popstash, kickhead, wait, what? Ah. Okay. Nope. It's a baseband sheet. Okay. So basically, side-to-side comparison is for the baseband RX, so which is the one on top. This has been replaced by ePod, basically. But this one has an this potentiometer is on the input, not at the output like on this one. Okay, I'm gonna say that I think this was done on purpose. This has been modified like to have a uniform architecture between the two paths. So I think we need to just modify this to be using the electronic potentiometer, and this is gonna be enough. I'm gonna do this and also at the same time ping Matisse, which is the designer of the previous revisions, with an S, so that he can confirm if my intuition is right. Okay, basically what we need is to place the MCP 4551. And we need two of them. And so, yeah, of course it's gonna be one or the other. So, let's make a nice box. And then we are gonna connect everything with labels, which I'm gonna create the one which is gonna be BB for baseband, RX, and then we are gonna have A, B, and W. BB RX B and BB RX W. Which goes here. here and here. This is gonna be okay. We can also split the boxes here and add the same labels on the electronic potentiometer. VSS is going to be connected to ground, which I'm just going to copy from here. It's fine. Okay, what was VDD connected to? Just VDD, okay. Oh, I see that there was, it looks like there was no decoupling capacitor, which I'm not a big fan of. So I'm gonna add some. Nope. Yeah, no. Cutting it in the middle is not gonna be nice. A0, okay, so, oh, I guess one is connected to A0, is connected to VDD, and the other one is connected to ground. Yeah, makes sense. So it was the baseband TX1, which is connected to VDD, so this one is connected to ground. Ground symbol for you. And this is SCL and SDA, which I guess are the labels still here. Yes, I2s, yeah, those. And then VDD, which I'm gonna again copy from here is good. I'm gonna add small decoupling capacitor. And if I move this on the side, maybe I can add the decoupling capacitor on the side of it. Okay, like this. So it's good. Oh. Sorry. Got sidetracked by a message that appeared on Discord. And I'm not even monitoring the correct chat. What a shame. Hey Manuel! How are you doing? Everything is doing good on my side. What about you? And this one we are gonna place, we are gonna set as do not populate. So either you populate this, or you populate that one, but not both. Okay, I think it's pretty clear what to do. Maybe I'm just gonna add a few labels so that we know exactly what is what. And so this one is gonna be E potentiometer with a dash. Okay, I think it's looking good. Maybe I can okay, so I'm just gonna copy this, put it here. Except that this is gonna move on the side, and this is gonna be connected to here. And so also this is going to be baseband TXA, baseband TXW, and baseband TXB. Same goes here. And here. Copy this and move them here. I'm gonna need to move that away so that you have space to put the labels. Let's see. I think this is better this way. Those are gonna move on this side, and this is gonna move here. And maybe I can, oh, can I draw, I don't think I can draw arrows, so let's not, I'm not gonna try. Okay, then I can go here, have both potentiometers on schematic. Closed. Nice. Okay, so maybe this is gonna get modified a bit at some point if I learn that I did a mistake. I don't know. I don't think it will, but maybe it will. If it's the case, I won't do the modification in stream, but I will just go and review the modifications I did off stream if I have to do some. Anyway, that's good as is. Now I'm gonna save this and do the commit. Basically need to okay. Next step is having both on PCB. Let's see. Is there any more modifications that we need to do on the schematic? Okay, this one I don't think I'm gonna do because I'm not able to do it, I think. Fix the audio output level. Maybe we can say that closed. So, oh, his connector is number 20, so I can just sorry, my spelling is bad. Anyway, so let's put that one as in progress because we haven't added the note yet. And this one I'm just gonna keep it there. So basically, we can start with the new enclosure. Great, finally. So let me show you what we decided for the new enclosure. I think it's that one. Exactly. Okay, and PDF is gonna show us. Okay, so basically, what did we decide? Given that we want the largest dimension to be less than 10 centimeters, we have decided a few things. Basically, you can see that this box, maybe I can, yeah. Basically, you see that the bottom face can slide out. So what we want to do is replace this face with a PCB. So you can see that the dimensions, the thickness of this is 1.5 millimeter, which is about the same as a PCB. So basically, we want to replace this face with a PCB on which we will mount keys and screen. So that way, you will have a pretty facing interface, human-machine interface, HMI, between the box and the user, instead of the one that we have on the PCB. And the side panels, so this one and the one on the other side, are gonna be replaced by PCB2. So those will be cut and have text on them according to the position and the type of connectors that we have. So we are gonna create openings in the PCB and write text to say that this is the audio output, this is the 12 volt input, this is the OHIS connector, blah blah blah. So yeah, we are gonna reduce an enclosure, remove the 3 removable panels and replace that with custom-made PCBs. But mostly what we want to do is make it so that you can still use Module 17 without having the enclosure. So we still have the screen and the keys on the PCB of the Module 17. It's just that the connectors are gonna get moved on 2 sides only of the box. And if you want, you can put this in an enclosure and add a few PCBs, add a new HMI, and so your bare board that you use for the as a TNC is now inside an aluminum enclosure, well protected, and much better and much easier to use. So this is roughly the goal, basically the board that you can use bare or in an enclosure. So we want to be ready for the enclosure, but we won't design it right away. So this enclosure, that the one we chose, has a dimension of 103 millimeters by 80. So basically 8 centimeters by 10 is the maximum PCB size, which is, I think, a tad bit larger than the previous revision of Module 17. And we are gonna have 10 centimeters on each side to put the connectors. So let's do that, shall we? So we are gonna open the PCB editor. Oh, maybe not. I don't know. Okay, maybe, yeah, okay. I'm getting lost because there are a few changes that need to be brought to the PCB. Yeah, okay. First, we do need to go here and assign footprints. Assign footprints to a few components. Oh, what on? Oh, this one. We are gonna have like 100 nanofarad for this and 100 nanofarad for this. Let me just check quickly the datasheet of the potentiometers. Do they advise any value for the decoupling capacitor? Do they give any example or something like that? scroll, 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 scroll. Doesn't look like it. Yeah, they don't. They don't say anything, it looks like. Anyway, decoupling capacitor never killed anybody. Oh, I2C, blah blah blah. Application examples. Anyway, keeping them anyway, so I don't care. So this is set. Restart assignments. PKL dipole C 0603. LM, okay, I don't know what that was. Resistor, is it PKL? Dipole, I guess, dipole, or yeah. MCP 602, and it's gonna be, oh yeah, I need to change that one to MCP 6002. And let's use the same as this, so package SO. This one, it's SOIC 83. Uh, 3.9 times 4.9, page 1. Yeah, okay. This is, yeah, this is the same. Okay, and the last one is the 8P8C connector is a bit annoying. I don't really know. And that one I forgot which one it was supposed to be. Let's see if there is any M17 smart mic. Doesn't look like. I should have checked for that. You know what? Let's use the same trick as we did for the electronic potentiometers. So that I can just go check out this commit. Footprint, I can just copy this, get out of here. And just like this, it's done. Amazing. We only need like footprint for 8P8C. I thought that there was like a specific footprint for the 8P8C connectors, but it doesn't look like it. I don't really want to go have a look at this right now. It's gonna just be annoying if I do this. So I think I'm just gonna keep it as is. Save this. Commit the changes here and here. And now I can start importing the changes. Of course, it's gonna complain that there is no footprint for J42, but we just decided to leave it be. Lots of components are gonna, oh yeah, okay. Yeah, because we copied a lot of things, lots of components have been renamed. The reference has changed, so I don't know if it's gonna do it or not. Let's see what it does. Okay, this is no good. This is really bad. I guess I'm gonna need to do some additional work, which I'm not a big fan of, but oh, maybe I can just, yeah, okay, I think we can use this to help us. So baseband RX, this was U7. C45, TP6, R37. This is not fun, but hey, at least I'm not gonna have to move all the components on the board. I guess this is supposed to be an 8. Yes. Not very well displayed. Anyway, 52, 55, 45, 46. 59, 43. 56, 42, 'and here, TP5, 6, 36, 38, 51, 40, 53, 55, And so this was C50, I guess? Oh no, it's 60. Like this. And this one is U7. And this is C48. Okay, so this is still a bit less names to move, components to move on the board. I still have those, which for that I think I'm gonna have to have a look. So let's stash and go check out this commit. Okay, so I can have a look. I'm gonna show this here. God, this is so cluttered. Oh, they decided to change the program again. Why not? Here, I don't think anything has changed. Or did it? No, I don't think so. However, here, few things changed. So this was J7. J4 this is new, so it's alright. Oh no, it was, yeah, 13. Let's reduce the same as we had previously, 69. Kenwood connector, the 2.5mm is J1 and the 3.5 is J5. This is 34, 32, 35, and this is J11. Steelink and UART come from microcontroller page, and speaker is just J12. Um, 12-volt inputs. This was J8. UART, it was 10. 9 for ST-Link. Resistor was 4 and 3. And for the USB-C, it was D9 or 15 or 16, U3, 28 and 29. Okay, great. Okay, so I think that those changes should help us re-import the changes on the PCB without having everything moving around. Maybe the last thing is this, which was coming from maybe here. Yeah, okay, FB3. Oh, this, yeah, of course it stayed the same, it's on the same sheet. Okay, so let's move to the PCB and import the changes and see. Okay, a lot more things updated. Okay. This is new. This is new. Oh yeah. Oh, forgot to rename those. The variable resistors. So let's go back to the schematic. And it was RV2 and RV3. Yeah, easy. Did I forget anything? I don't know. Basically, we have this and the two new connectors. His connector with the two. No, this is the USB-C. Oh, USB-C hasn't been renamed properly. Crap. What was it supposed to be? J2. Yeah. Just checking quickly if I forgot anything. Hi Bastien, how are you doing? So here, apart from this, everything should have a new name here and there. And connectors, yeah, those two are new. And then finally, this is all brand new components. These two, okay. Basically this is a drop-in replacement. Just gonna try to keep it. Oh yeah, this one I should have renamed to. Okay, you know what, it's gonna minimize the risk of errors. IC201 and it was IC1. Then there is just this that I have to place. Okay. I'm doing fine. Watching this on a big screen, like, is it cinema sized or what? Okay. I'm gonna start by. Well, this can move out of the way, and we are gonna draw the new outline of the board. So it is on the edge cut, and we are gonna create a rectangle, which is gonna be 80 millimeter by 100. Okay, this is the new size of the board. On this side are gonna be this connector, which let me just check how it is aligned. Yeah, basically I think I can just move this. Well, this is the big question, like, to make it easier, can I start from this instead of rerouting everything, which is gonna take a huge time? I'm gonna try doing that. So so the PCB, I don't think it's gonna have rounded edges anymore. We can remove the old outline. Well, not rounded edges, but rounded corners rather. Okay, like this. Okay, I think it's gonna be a nightmare anyway. Let's move those out of the way. Let's unlock this to move it out of the way, because this is, we don't need to place this at specific places. Those we can group together and unlock them. Move this out of the way. Oh, a small heart, didn't see it. Unlock it. Wait, what? Oh, what the hell? Guys. Okay, group. Okay, like this. And group and move. You are seeing all the small secrets from the board, all the hidden writings. Okay, so from a logical perspective, we should have on one side of the board packet connector, USB-C, 12 volt, and the multi-turn for the baseband adjustments. On the other side, we should have OHIS connector, Kenwood connector for the audio output input, and the speaker volume knob, which is this one. So it means that those keys need to move probably, and these also need to move. So those, let's group them. This, what is it supposed to be? It's just a drawing. I don't really care. Those are gonna move together, so it ensures that we keep the same spacing between them and keep them aligned to the same distance from the edge of the board, let's say. Okay, we have quite a few things. Oh, I wanted to add another connector too, which is part of the enclosure redesign. Well, the adaptation for the new enclosure. Yeah, blow it up. I'm afraid that it's gonna require more time to blow it up and redraw everything than just modifying bit by bit. Hi Andy, how are you doing? Long time no see. Let's see. This is barely readable. Right, first, those can be modified to suit the new form factor let's say. So this comes here, this goes here, and those two corners go down here. Nice. Yeah, so the case we have in mind is basically this one, which you can have a look here. So the color, it exists in like 3 colors, like gray, black and red, I think. It's not what's most important. But we are gonna reuse this, remove all the side panels and the bottom panel, and replace those 3 pieces with custom-made PCBs and slide just slide the Module 17 in it. So which also means that we have to keep 2 millimeters on each side free from everything, so that this can slide in the enclosure. So yeah. The display would go, yeah, on the front panel, the one that you remove, but mostly there is still gonna be a place to put a display on the board, because we do not want to force users to use an enclosure. So you will just have somewhere to plug the new HMI, if you want, with the LEDs, buttons, screen on the case, on the enclosure. And from there you're gonna have like a flat cable, a ribbon cable, whatever, that you will plug on the Module 17. So we will have to add connector on the board, but this is for later. For now we have to figure out how to fit everything on the board, which is the most important, because the board was already quite a bit crowded. I think we're not gonna cut it. We have to kind of start from scratch, I believe. Which is still annoying, because the more work we do, the more mistakes we can do, which I'm not a big fan of. Yeah, okay. Anyway, this will go... Oh, wait. What's that? What the hell? Okay, whatever. This move out. And we are gonna place the new origin. Let's place it here and align this on here. Okay, let's add a few measurements. And place this one on user commands. And a new from here to there. So I'm gonna place on the same layer. Okay, from here we will have on this side the volume knob, and then next to it are gonna be audio output connectors. I'm just gonna place them next to them, and we are gonna do the pretty layout later on. So what we need to add to is placeholder for the the OHIS connector, which I'm gonna keep like 18 millimeters for it, and it's gonna be user drawings. Okay, and on this side is going to be packet connector, USB-C. Well, I'm going to have a look. Oh, it would be nice to have the OHIS connector. Okay, this we will have to decide, but do we want the OHIS connector and the Kenwood connector to be self-interlocking? So what I mean is that when you plug the OHIS connector, you cannot plug Kenwood one, and vice versa. I think it would be more foolproof that way. I don't know. Might be a good idea. We might want to check that. Then we have 12 volts. Yeah, I think it goes like this. And then that's pretty much it. We don't have any other connector that we have to add, I think. So that leaves a fair bit of space. So maybe we can add like the screen. Oh. Group. So this would be, oh no, group like this. So we might have like the screen here. The buttons here, and the power button here. So this might be an ID, let's say. Oh, this one has to go here. Oh, watching with no audio. Okay, what else do we need to take care of first? This one, it's better if it's near this one. Oh, I think oh yeah, okay. I need to put back those around here. Anything else? Oh, I think this is hard to read. I think this is for this connector, is it? Would make sense. Yeah, all kind of tracks that we are gonna have to retrace. This is gonna need to be near the audio output, so maybe here. So this is the audio stage, so it would make sense to have those two going close to, yeah. Yeah, crap. No, I need to. Okay. Okay, basically like this. We are gonna figure things out later, as always. This connector, maybe we can just add it here. Reset button. Yeah, maybe first let's take care of user comments here. We need 2 millimeters of clearance, I think. Wait, where can I? Oh, maybe. No, okay, I'm just gonna do it here. 2 millimeters edges, and we are gonna name. Is it text box? Oh, okay, that's why. Two millimeters. Filled shape. You? Okay. I apparently screwed something up. Yeah, okay. Filled shape like this. And copy paste to put it on this side. Are you going to stack the front panel with more than one row? Oh, okay. Okay, so yeah, let's settle on some denomination. This is gonna be a right face, left face, or maybe front face, back face, and top face is gonna be the HMI that is gonna be designed later on. No, I don't think we are gonna design this to have more than one row because it's too complicated. I think it would require more than one PCB, which I don't want to do, or it would need very specific parts, which I don't want to have to look for because it's always a nightmare to source them and then to keep sourcing them in the future. So if we want people to be able to manufacture the board easily, we can't allow that. So connectors are going to be on the front and back face, and on the top face, which is the top face is the one which is going to be, so basically take the enclosure that you see here and you flip it. So the removable face is going to be the top face. and this is going to be replaced by an HMI. I hope it answers your question, Jay. Great. Okay, I've been streaming for about nearly 2 hours now. I'm gonna make a small break, brew a cup of tea, and then get back to this. So see you in a few minutes, guys. Maybe let's say, yeah, about 5 minutes. See you guys. Okay, welcome back. Yeah, case is upside down, just like OpenH is upside down. Basically, yeah, everything is upside down. It's funnier that way. Anyway, okay, so what I would like to try is so lay out first all the major components, and then route everything. Maybe I can try to keep all these together. So what is this? Oh, those are the, yeah, baseband filters. Okay. Something else I didn't do. We wanted to change the variable resistors here so that they would be accessible from outside the enclosure. So let's go back to Taiga and have a look here. And this was the multi-turns that we wanted to use. I don't know what the package of the current ones is. Let's go see in the schematic editor. R224W. Oh, it might be the same actually. R224W-1. Yeah, W is top adjusts. Is it the same? No, side adjust. Okay, so we should go for R224J. So basically this one. So we are gonna need to design, or maybe just pick it. Oh yeah, this one. R224J. Okay, that's it. As simple as that. So modify this one too. Yeah, I thought about that, Jay. I'm gonna decide. We are gonna decide on that whether we want to order some or not, and then try. This is just detail, so we will figure that out later on. But we might indeed want to order some under the revision 0.99 just before having revision 1, so that we are sure, definitely sure, that the revision 1 is working and usable by everyone. Wait, what? Wait, what the hell? Why do I have to add and remove everything? Okay, those don't have anything in the schematic, which is bad basically. So let me just see footprint H3, which is this, and we should go here. Oh, wait. Why is it complaining then? Or maybe it's complaining about something else. Oh, is it complaining about... Oh, okay. I think it's complaining about like this. Yeah, okay. There is still one item that needs to be specified as being not in the schematic, but which one is it? So this we can remove. Oh, I think it's this one. Yeah. Great. So now... Oh, still one. What would it be? This can't be. Uh-huh. Is there anything like in here? What the hell? We have some item somewhere and it wants to remove it. Oh, this one? Is it? No, it's just polygons. We are gonna find it and exclude it from the schematic. Just have to know where it is hiding. Ah, this one? Really? Hahaha, yes. Okay. Okay. Just having my cup of tea. Cheers, guys. Okay, so one thing I want to do is maybe move all of those to the underside of the board, because I don't know if we are gonna have enough room to route everything and have the logos. Coffee, yeah, it's a bit too late here to have coffee. Maybe like if I had to release the board by tomorrow, I would be having coffee at that time. Yeah, okay. I wanted to do the connectors. Okay, so this does need to move on the side because it's colliding. Okay, so they have like a bit of clearance. So as a reminder, those are the 2mm that are gonna form the rails, which are gonna be used to slide the board in the enclosure on each side. We have 2 millimeters of clearance. So this is the display port connector, and we have the USB-C connector and the 12-volt barrel jack connector. And then we have the 2 variable resistors, which are okay, here and there. What the hell? Okay. Can we fit both? Ooh, this is gonna be tight. Let's see. First, let's see how they should be placed. So I guess the adjustment is here on the left side, so this should be facing this way, I guess. Oh yeah, good call, Jay. Fasteners holes. Yeah, we should try to keep them. You are right. Okay, I can't figure out the distance from the edges of the board. It looks like it was like 3 millimeters from each edge. Yeah, makes sense. Let's see if we can keep those 3 millimeters away from each edge. Yeah, of course it's gonna overlap the rails, which I don't know if it's a big deal actually. Just in case, let's move them. Is there any advantage in having them so close to the edges? I think it's better to be safe than sorry. So I would rather move them so that we are sure that it's gonna be good enough. Also, keys to be somewhere else. I don't know. This. think it's gonna clash with the screen. Yeah, so this is no good. Screen needs to move. Maybe we can simply move it this way. But the keys are not gonna... Oh, maybe... let me think. This can move down. So this one, let's see how it goes. We can just move this cap. If it's the only problem, it's gonna move. Yeah, but we still need to move this out of the way. Wait, I need to move the text labels alongside it. And so this one is... Okay, let's lock everything that needs to be locked in place. Okay. Okay, so the keys, yeah. I don't know. Looks like the keys are gonna be annoying. I want to try to keep them in the same disposition if possible, so that people that are used to using it do not have to relearn the new disposition. If you are looking at the case that I showed, Jay, no, okay, Jay, if you're looking at the same board as I showed, which, so as a reminder, it's this one. Here is the reference. So 1455L801RD. Then you can just remove, so this is the, I guess this is what you call the belly plate, which I call the top face, because it's the one which is gonna be replaced by an HMI, you can just remove it and slide the PCB inside. The only downside is that the PCB is not gonna be flush with the rest of the case. It's gonna be a bit recessed by a few millimeters. I don't know how much, like about 3, 4, 5 millimeters, something like that. But this is the same thickness as the PCB, and the rails, well, the rails are those features from the enclosure. We can just slide the module 17 in it, and that's it. Okay, let me think about, okay, maybe we can try another disposition for the screen and buttons. Maybe we can try to have them like, crap. Okay. No. Okay. Maybe we can try to have the screen. Nah. Crap. Screen here. Oh my god, there are too many labels. I don't know what to do with them. So the screen can be moved like here, and the buttons can be put just here. So that would leave maybe some space for, like, we can move those maybe here, something like that. We have this capacitor, needs to be somewhere, and this leaves some space for the processor and all, and then the two baseband filters, we can try to mount them about here, I guess. I like to put a mark in the middle, so that would be 4 centimeters below this line. Okay, so this is just to indicate that this is the middle of the board. So if we want to keep things aligned and pretty, we should try to center things around this line. So for example, the keys are too high. And the screen, I guess, Okay, so this way everything is aligned properly. Power button, where do we want to put this? So connectors, this, yeah, you can put this here. And this one, you can put it on the edge, I guess. Not very important. This one too, you can put it on the edge. So what is left? This is the level conversion, I think. This is just something that I think could stay near, yeah, like near the processor. This is gonna stay here. Yeah, this is for the ST-Link connector. Like this. UART one. It's for this connector. LEDs. Where do we want to put LEDs? Here would be a good place, I think. Oh, do we have power button? That would be good if we have like power button and LEDs right next to it, I think. Yeah, great. What is this? Oh, it's the filter for the analog amplifier parts. Yeah, okay, end panel is... It's left and right or front and back depending on how you rotate the case, basically. From my opinion, and this is just why I said I'm gonna call this that way, it's gonna be held like this. Like if I exaggerate the proportion, have it like this in front of you. So basically this is gonna be front and back. Whatever, basically it doesn't change anything. Long side, short sides, and that's it. Okay, so now that we have cleared up a bit of space around here, we will be able to move a few things. So what's that? I don't remember. Oh yeah, this is the USB connector circuitry. Let's... Yeah, okay, not a big deal. Yeah, screen orientation and buttons will dictate how you look at it, and that's why I think it's better if you have the wider side facing you. Just like portrait mode. Anyway, the top panel is not gonna be designed now. It's gonna be a bit of time before we can have some time to design it. So yeah, it's for later on. Okay, I just want to check something. I think something just popped in my mind. I think some time ago we might have spotted something going on with this. Yes, Andy, we are using USB-C. Okay, I think it looks okay. I think if I remember correctly, we had like at some point somebody hesitated with this, and we thought that we might have a problem with this. I don't remember. We'll see later on. Let me just tag somebody somewhere so that at least we know that we have to ask those questions. Which the first one, okay, basically this and this is gonna move and go near here. Yeah, using IPHC would give us more space on the board. We even discussed using Minidin because it's so Minidin 6-pin is what is used in the by some big manufacturers like Yaesu, ICOM. But in the end, we decided to keep the connector that we used previously because we didn't want people to have to remake a cable. So yeah, we just decided this. Yeah, yeah, I agree, but some people do not have such crimping tools and have a hard time doing such finicky work. And also, some people already have the cable, so for those it's gonna be much faster. Anyway, it was a choice. We will see how it goes. Maybe later on we might decide that we want to, I don't know, switch to another kind of connector. I also think that somebody sells connectors, cables, assemblies, which already fit this. So I think you can even buy some which will do what you want, which is even better for some people. Wait, why can't I move? Okay, crap. Let's see. Can I keep the... Oh, what? Can I keep the center of the buttons aligned on the grid? Wait, something is going on? Okay. So, okay, the center of the buttons aligned, and so I can do this and align the power button with the rest. Well, it is aligned, great. Good enough. Okay, let's see. That's what it would kind of look like for now. Okay. Yeah, center the LED on the power button. I don't know when you wrote this message. It's kind of, yeah, not exactly the case yet. Well, it depends on what you call centering, like, I think like this, it's centered. Yeah. Yeah, is it centered? I don't know. Anyway, this is details we are gonna figure out later if we want to tweak a few things like that. Oh, YouTube decided that I hadn't the right to use music anymore. Oh my god. Let's bring back the MCU on the board. Okay, I would like, if possible, to move this. Yeah. Okay. Okay, that's what I thought. It's gonna be difficult to fit everything in this tight corner. Okay, let me have a look, because I want to avoid having like the screws from the DE9 connector getting in the way, but I don't think it's gonna get in the way anyway. So maybe I can just move that much closer to this side. Like this. Move this. Yeah, and this also needs a bit of clearance around it because it's gonna interfere. This can move this way. I don't think it's gonna give us enough clearance anyway. So we have to add, this is gonna have to go to the near here, and this I think it's mostly related to here. Those are gonna go here. This one, yeah, this is all this is except which one is it? This one go here. No, it doesn't. It goes here. Why do we have so many ones? So many. Oh yeah. Okay. No, sorry. Okay, this is all good. Everything belongs here. Those two. I think they go with those one. Oh, took the measurement with me. Like this. And this goes with here. Let's see. This is the decoupling capacitor, which can go here. And this one, we can put the capacitor here. Great. Then we have this, which is the amplifier, the double amplifier for the two filters, the two, two amplification stages. what's going on. Okay, yeah, so this is a silent key filter, and this is... Oh, is this a 3-pole silent key filter? With a first buffer? Or what is it exactly? I'm not sure I understand. Okay, let's try to figure out a way to fit the filters on the board, and then it's gonna be good to go. And we will close the stream, I think, because I'm getting a bit tired. What's this? What are those large capacitors? Oh, 22 microfarad. Oh. So... Okay, oh yeah, this one has a lot of big, large capacitors. 2 here and 1 here. Okay. Oh, this one has... no, 3. Where is the third one? Okay, here. I see. Why do we have like... Okay. Maybe we should add in some documentation. Okay. Like, do we have the space to fit everything? I don't know. Radio TX. I'm pretty sure this can go, yeah, like here. And this can go like here. Maybe those can go here too. So yeah, we can clear up a bit of space for this. And then maybe, so we have like this one, which I guess is gonna go, no, maybe not this one. Oh, we don't have any blocking, DC blocking cap here. so we need to cram all this here, which is not nice. So this can go here. This can go. Pretty sure this one can go. Yeah, near the connector, and we have R52 which can go there. Is this still needed? So my guess is that those are not needed anymore, and C58 can go near the DE9 connector. And so this, yeah, okay, so this, and this, we can move it around here. So that's a bit less components to fit in this small space we have. Hey, look at that! It should be able to fit somehow. Yeah, should work at some point. You just have to route everything and all. This is for the cat level conversion, I think, and this is for the PTT, and this is like just generic analog, which can go basically anywhere on the board. Preferably this one would go preferably the PTT level conversion would, sorry, I code the levels. So this radio PTT, this would live here, and this would live like somewhere here. And then we have, this, which is the power stage. So maybe then we can move those go here. And this, maybe we can drop it down a bit. So we can also have, oh my god, there are too many labels on this board. It's a nightmare. So then we would be able to cram the power supply part near the power connectors. Okay, it sounds like a plan. Oh, this one has been removed from where it lives. Okay. Yeah, this is like the analog ferrite bead and all, which can go here. Okay, so let's remove the ground planes we don't need. And this basically needs to what is still locked? Oh, this is locked. Not anymore. This goes here. Okay, a few test points that we need to move and all. That's not a big deal. And yeah, so we next thing to do is try to fit the power supply somewhere. Maybe I can try to just move a few things around, and this, so we can try to keep it arranged. I don't know. We will need to find a spot to place the power supply and then start routing, basically. Yeah, it's gonna be tight. Oh, and we also need to try to keep oh, maybe we can put the connector for the enclosure, we can put the connector under the screen, because we most likely will never be using both at the same time. So if we put a flat connector here, we can have the flat cable go from here, go over the buttons, which might be there or not, depending on the previous uses of the board, and then go to the enclosure HMI. Oh, that would be nice, I think. And just as in OpenHT, I'm trying to keep everything on the same side of the board, so that we don't have to increase the price for double-sided assembly, which is always more expensive. Okay, that's gonna be it for today. that's gonna be it for today. Thank you for following along. I hope you enjoyed the stream. Oh, sorry, Jay, I didn't see. OLED display is off the board on standoff, so maybe there is some real estate there. Fastener holes for the display. I never used Module 17 yet, so I don't know if it's really needed. I never saw anybody complaining about that, so I think it's rigid enough. It's not very large, so I think it's good enough like this. Power stage under the display, yes, except if I put the flat connector for the HMI there, then maybe we'll need to real estate, because it needs quite a bit of space on the board, I think, for the connector itself, and then the space for the cable to at least go out and then go up to the HMI. So yeah, there is some real estate there, but I do believe that if we move this around properly, we will find the space needed to put everything together, power supply around here, I think. Yeah, maybe 2 holes are gonna be enough. I don't know. I have to say it's not gonna be a priority, but if I can fit those, why not? Thanks. So yeah, I think we did quite good today, actually, compared to some other streams. Oh, you had glued on yours, okay. Okay, yeah, I see. Okay, well, I'll try to keep that in mind. Fasteners holes for the display, this is not a big improvement, and most of all, it's not an electrical modification of the board, so not a big deal. Okay, that's it. I still don't know what is going on here, that this wants to... so weird. Oh, maybe it's... No, I don't know. Thought it was because of the copper door below. Anyway. Let's close this, save this. I'm just gonna review quickly what I did as modifications on the schematics. Yeah, basically some things moved around, and that's pretty much it. Same thing goes here, I think, and the PCB. So except that on this one, I think there was something I wanted to modify. Let me check. Yeah, the footprints for the variable resistors. Okay, and this. Okay. Okay, that's gonna be it for today. Thank you for following along. I hope you enjoyed it. It was quite a long stream today. I don't know when the next stream is gonna be. Might be tomorrow, might be later on. I'll see with the time I have available. Anyway, I'm gonna tell it on Discord ahead of time, so keep an eye on the Module17 dev channel and eventually the M17 live channel, on which I try to post the link before the stream starts. So 73s everyone, hope you had a good time and see you later.